Secal produces drying systems and kilns featuring advanced concepts at both the structural level and in terms of applied technology. The particular structural designs adopted ensure lower levels of thermal dispersion and, above all, long product life, stable performance over time, and a decrease in the need for maintenance. Exclusive extruded aluminium sections represent an optimal and definitive solution as regards resistance and hermetic sealing requirements in each of its prefabricated drying chambers. The load-bearing structural truss frames and sections, all of which are produced as single-piece elements without jointing, are constructed using special templates, producing an arched profile characterized by a particular deflection. This technology allows the system to bear loads much heavier than those that would be supported using horizontal beams parallel to the ground, or, worse still, very low-cost modular truss systems that would be convenient only for those who produce them and keep them in stock, but certainly not for the user. The result is an extremely solid framework, complemented with opportune forms of insulation presenting the best functional characteristics available in the market. Special interlocking profile sections supporting each insulation mattress and specific highly resistant sealing elements ensure that the walls of the drying kilns withstand any expansion, also in extreme climates, without suffering permanent deformation of the paneling and, above all, the sinking or collapse of the insulation itself. The ventilated walls, constructed using preformed sheet metal sections presenting a Greek pattern design, are capable of forming externally a large number of small, parallel, vertical channels that provide a flue or stack effect. When it gets warmer, as a result of solar radiation, the air present in the cavity of the Greek-style sections tends to rise and is expelled at the top, thereby forcing more air in at the bottom. The natural air circulation thus generated ensures optimal performance of the insulation and preserves it over time, keeping it dry and free from condensation. From a functional point of view, the ventilation fan has the hardest task of all. The Secal fan was designed in collaboration with a prestigious university and built to ensure a very high level of performance and low power consumption. In-depth fluid dynamic studies of rotor blade face profiles have led to a significant reduction in friction, and, together with the spherical and parabolic geometry of the hub, has allowed for a reduction in the number of fans installed, maintaining performance unaltered in terms of the amount of air moved and the fan head rating. A significant amount of energy is thus saved. We can also easily demonstrate that a drying unit fitted with 6 Secal fans ensures the same performance as a conventional dryer equipped with 7 fans of the best quality available in the market, and that energy savings amount to about 15%. Multiplied by the hours and days of operation, this can add up to as much as 27,000 kilowatt-hours per year. Produced with the shell mold casting method, the Secal fan presents a quantity of aluminium which is twice that used for traditional fans and is more robust and durable. The particular blade profile used generates reversible ventilation, which by inverting the direction of rotation, and thus the flow of ventilation, allows the mass of hot air in the kiln to preserve unchanged its holding capacity, pressure, distribution, diffusion and turbulence in both directions. The Secal fan nozzle, produced entirely in stainless steel, is much different from and far more resistant than low-cost stamped nozzles made of simple aluminium plate with a single edge, or worse still, with no edging at all. A double edge, the only disadvantage of which lies in its presenting higher production costs, allows the fan, together with a particular blade profile, to achieve full reversibility and thus the same behavior in both directions of flow. Its rounded profile allows for an acceleration of the air close to the outermost part of the blade, extracting higher volumes also from peripheral areas, where the blade has a higher speed and thus the highest yield. On account of the very low deformability of stainless steel, Secal was able to increase the length of the blade and leave only a 5 mm tolerance from the edge of the nozzle. This particular solution, which would not be possible with elements in aluminium on account of the deformability of this material under the effect of accidental overloading, with snow for example, allows for a greater movement of volumes of air with equal effort and thus at an equal level of energy consumption. The structural sizing of the motor seating, produced with 4 mm thick stainless steel plates, has been reduced to a minimum, thereby allowing for a very significant reduction of the negative effects of turbulence. Secal technology also provides for the breaking up of water particles, or droplet micronization, effected by a high-pressure system reaching and exceeding a pressure of 100 bar. Driven by a high-pressure pump through stainless steel nozzles with a die-orifice outlet in highly resistant ceramic, the micronized water acquires a velocity and turbulence whereby the infinitesimal particles of water that are produced, referred to as type A mist, are so small that they remain in suspension, floating also at low temperatures, just like fog during the winter months. This avoids fastidious dripping and undesirable staining of timber sections caused by impact with insufficiently nebulized water, which often occurs with traditional 4-bar nebulization methods. Forced humidification, which is highly active and efficient also with low temperature regimes, allows for greater relaxation of wood fibers, with penetration into the innermost layers and a consequently more homogeneous drying process with stress-free fibers. Considering that a lot of energy can be saved, especially during the winter months, Secal systems provide for the recovery of heat from outgoing exhaust air, a solution that can be easily installed also in existing systems and at any time with no need for substantial modification. A heat recovery unit is installed for each pair of flues for air supply and extraction. The heat recovery units are capable of transferring heat from the warm, moist air, which is about to be extracted, to the cold, dry air restored to the kiln or chamber. Through passive thermal exchange, and thus with no further energy consumption, on average about 50% of the heat normally dispersed in the environment is recovered. Being fully reversible, the recovery unit operates without hindrance regardless of the direction of airflow. These units can also be fitted with extraction fans, where it becomes necessary to compensate a fall in pressure levels due to air channeling, or where it's necessary to improve the extraction operation. The automated control and management system is enhanced with numerous functions and provides in real time all necessary information concerning the state of the system, including the expected duration and the termination of processes. On request, the electric control panel and switchboard can be equipped with a highly functional, modern, industrial-type PC featuring a gas cooling system without ventilation, low energy consumption, and a 17-inch high-gloss touchscreen. The anemometer provides the system management and control units with useful information concerning the condition and quality of the air circulating around and through the stacks of wood. The Secal ultrasonic anemometer not only measures airspeed, but also air turbulence and therefore provides essential information about the quality of airflow. Combined with an inverter, Secal anemometers are the perfect complement for the automated management of the speed of the air, which will be circulated solely in accordance with actual needs, thereby allowing for substantial energy savings. In the event of excessive kiln loading or an unsuitable choice of plank size, the system itself will compensate for the error, providing increased ventilation. Each anemometer detects moisture equilibrium and temperature values with measurements taken directly at the centre of the piles. This allows for earlier expulsion of moist air and thus an acceleration of the drying process. The complex automated management system used in the timber drying process, which provides important feedback, replaces the daily monitoring of drying cycles on the part of the operator and facilitates the optimization and an acceleration of the process itself. At preset intervals, the system checks the current situation and assesses the progress of drying, autonomously modifying the temperature and EMC, or equilibrium moisture content, parameters provided by the program. It will also decide to accelerate or slow down the process in order to primarily observe the daily decrease of wood moisture levels according to the set established ideal value or a customized curve, avoiding typical and quite frequent stalling that can occur during the dehumidifying process. Secal has made a strong investment in research applied to the evolution of IT instruments such as computers, mobile phones, smartphones, iPads and so on, which have been linked to the technology already developed by the firm. One of the most important results can be seen in the Secal monitoring remote control and teleassistance system, now well tested in the PC version and providing highly innovative functional aid in the mobile version. With the help of mobile devices such as iPhones, iPads and Android smartphones, and also dedicated software, it's possible to interact directly with the drying system and all of its functions. Together with the remote control function, the communication system provides a very valid tool, offering operators the security of the constant presence of the controlling and monitoring company for any issues that may arise. The Secal system offers state-of-the-art product engineering and manufacturing, thermal efficiency, aerodynamic designs and optimal functions achieved without restrictions relating to construction, efficiency and savings in terms of energy use without influencing performance levels, long-lasting effects of maintenance and fewer servicing interventions, homogeneous drying, and a remote-controlled operator interface providing all required information. These are the strong points of Secal's new high-efficiency drying plants.